Alright, okay, so last time, last class, I will complete about the estimation. Okay, so next tools in the statistical inference is that you want to test the hypothesis, okay? Or hypothesis testing, okay? So a hypothesis is that we have an assumption or we have a previous information or history information. So now we collect the data. We want to prove whether there is a changes in based from the previous data, or is the assumption is correct or not. Okay, so that is why that you need to use to do the hypothesis testing. Okay, still the same. You use a data sample, a sample from the data from the sample to test the hypothesis for population. Okay, still in the statistical, right? Use data sample to test for population. In estimation, use sample data to estimate for population. Okay, so whatever it is in statistic, we just use a sample data, but we don't make a conclusion about the sample. The conclusion or the testing or the assumption based on the in the population, right? Okay, so in hypothesis, okay, so the first hypothesis, okay, the conjecture hypothesis, the first one is we call it is a null hypothesis, okay, HO. Normally we use HO, null hypothesis. The opposite one, okay, we have two hypotheses. You have to develop two hypotheses. Every hypothesis must have a null and alternative hypothesis, okay. So the opposite of the the alternative must be the opposite statement of the null hypothesis. Okay, so if the null hypothesis is equals to or that value, there is a relationship between certain variables. Okay, so the alternative hypothesis is that no relationship. Okay, so null hypothesis. Okay, so normally whatever you want to test, okay, let's say we have you have assumption previously. Let's say average grade or CGPA for BBA student is more than 3.5. Okay, so that is based on the previous data. Okay, so now I do some data, I collect the data, okay, from a sample from BBA students, okay, and then I test. So then that conjecture or the assumption that the previous data show that average CGPA is more than 3.5, that statement or that hypothesis, we should put it in the hypothesis alternative hypothesis, okay, not in the null hypothesis, okay. But however, the decision is to either the based on the figures, we will make a conclusion based on the null hypothesis, okay, not the conclusion about the alternative hypothesis. Okay, remember the statement is you put in the alternative, whatever you want to test is in the hypothesis alternative. Okay, but the decision is made based on the null hypothesis, whether it's a significant reject or not reject based on the null hypothesis, right? Okay. Okay, so first, before you develop the null or alternative hypothesis, okay, so for you have to understand the context of the situation, okay, right? So you have to understand the context before you start develop the null hypothesis. Okay, and then normally okay, so in the hypothesis same as previously, okay, you collect data based on a random sample or whatever method that you use for sampling, okay, and then based from that sample result, we make a conclusion, okay, right? So just to make sure that your data, your sample is random, okay. Right, or you want to create the hypothesis. Okay, so first you have to know that why is it you want to collect the data, or you want to collect the sample data from the sample, okay, and based from that data, what conclusion that you are hoping to make, okay, right? So I just cannot go and just ask the student, okay, what is your CGPA, or from the database, okay, I just want to identify the student's grade, okay. But we have to identify why is it that I want to do that, okay. So based from this grade ni, what is the conclusion that I want to make? What is it that I want to see? What is the difference if the result shows that the average student CGPA average CGPA student is more than 3.5, okay. What will happen if based on the result shows that average CGPA student is less than 3.5 actually, okay. Alright, so what is it that I want to conclude based from that finding, okay. So you have to, you cannot simply go and make a conclusion, okay. So first, when you want to collect data, so you have to know the purpose of that and the conclusion. Okay, so hypothesis testing, remember you have a null and hypothesis, okay. So first we will go into the developing hypothesis for mean, population mean, okay. For mean first, okay. Alright, so there's a three form, okay, of hypothesis, okay. So HO here is null hypothesis and HA is alternative hypothesis, okay. Alright, so these first two, okay, first two alternative is one tail hypothesis, okay. This is one tail and then this is a two tail. This is a equality, okay, equals or not equals to, okay. So this one is more than or less than, okay. So one tail, this one is one tail and this is a two tail, okay, two tail test, okay. What is the difference between two tail and one tail? Later I'll explain, okay, because it will determine your so your confidence level, okay. The difference is in the confidence level or alpha value, okay, or significant level. Alright, so one tail and two tail, okay. So null is okay. So for hypothesis null, equal signs, okay, must be in the null hypothesis, okay. You cannot put it sorry, mu as let's say you want to put mu, sorry, hypothesis null, mu is more than or more than certain more than 3.5, okay. The mean is more than 3.5 and then the alternative hypothesis is mu less than or equals to 3.5, okay. Okay, so it's wrong, okay. So the equal sign must be in the null hypothesis, okay, cannot put in the alternative hypothesis, right? Okay, so remember this is a one tail and this is two tail, okay. Why is it one tail? Okay, this is I mean that will determine the rejection area, okay. So one rejection area only and this is two rejection area, okay. All right. Okay, so this is a competition not only for one tail. I think it's for hypothesis testing lah, either one tail or two tail or proportion. Okay, same method. Okay, so first you have to calculate the value. Okay, the t value. Okay, based on the equation. Okay, later I will show you equation. So first identify the t test. Test statistic. Okay, all right. Either T statistic or Z statistic, okay. Remember, same as estimation. Mu for mean population, if you want to estimate mean population, we will use T test. And to estimate proportion population, you use a Z test, okay, same as hypothesis, okay. To test the hypothesis, for mean, we will refer to the T distribution, and to test the hypothesis for proportion population, based on the Z test, okay. All right, so using the test statistic and then identify whether the T test or is T test either lower tail or upper tail or two test, okay. And then identify the area, which area that based from that value too, we identify the area for rejection and non-rejection region, okay. All right, so and this is this is for two tail hypothesis, okay, two tail test for population mean, right? Okay, so this is the formula that first you have to use this formula to get t value, okay, t statistic. This is what we call t statistic. T is for mean, okay. For population proportion is z, okay. So but the formula same as. Similar as mean lah, actually it's derived from the previous one, okay. All right. Okay, so this is a distribution, normal distribution. Okay, so this is a normal distribution. So this is a sample of two tail. Okay, two tail. Okay, so based on this, this sample for two tail. Okay, so this is two tail. Why is it two tail? Because we have two area here. Okay, so in the hypothesis, the first thing you have to identify the critical value here. Okay. Okay, so first identify the critical value. Okay, how you can identify the critical value? Based from the alpha value or confidence level. From the confidence level, let's say you use a 90% confidence level, then you can get alpha value. Okay, or you can identify directly the alpha value or significant level is 0.05. Means that you know that your confidence level is 95%. Or you can just determine your alpha value is 0.1, means that your alpha confidence level is 95%. Okay, if your alpha value 5%, if your alpha value 0.1, your confidence level is 95%. Okay, so you can determine either one first. Okay, you want confidence level or alpha, which one comes first doesn't matter. Okay, so you know that that is the opposite of the other one. Okay, all right, so to get the value for T critical, so based on the alpha value, then you will refer to the table. Okay, table that I already explained previously. Okay, alpha and degree of freedom, then you get the T critical. Okay, so T critical will determine, okay, the area. Okay, when you get T value here, get T here. Okay, T critical. Okay, so this is will determine the border. Okay, the border for area that which one which area that you you will reject the null hypothesis or you do not reject the null hypothesis. Okay, so that's a T critical will determine the rejection area or rejection region. Okay, alright, based from the alpha. Okay, so your alpha, if your alpha is you have a lower alpha, means that the rejection area is quite small. Okay, if you have the higher alpha, the alpha value is border compared to the lower value. Okay, all right, so then after you get the T value, the next is that you calculate T. Okay, T statistic, calculate using this formula. Okay, so after you get the value here, then you can compare the T value is either in this area or in this area. Okay, so this is a rejection region. Okay, so this is a rejection region and this is a non-rejection. Okay, non-rejection and rejection. Okay, so rejection area, okay, so rejection area is based from the alpha because this is two tail. Okay, so two tail alpha you have to divide by 2. Okay, if one tail, then you don't have to divide alpha by 2. Okay, alright, so two tail, then alpha divide by 2. Total here, okay. So this is your confidence level. Okay, let's say we use a 90% confidence level. Okay, alright, so 90% means that this area is 90%. Okay, so 90%. So the rest here, these two area is 10%. Okay, so these two area is 10%. Okay, both 10% because in total the whole area is 0.99999. Okay, so, nearly to 1.0 lah. Okay, why is it not 0? Because the border here, the line here, okay, cannot touch the vertical line. Okay, alright, so normally you get the value is 0.9999999. Okay, alright, so nearly to 1. Okay, or nearly to 100%. Okay, so if your confidence level is 90%, so the rejection area is 10%. If you have two rejection area, means that you have to divide by 2. Okay, alright, so this is 10 divided by 2, 10% or 0.1. Okay, so this is 0.1 divided by 2 equals to 0.05. Okay, so this is 0.1 divided by 2 equals to 0.05. Okay, so the array, so the value here will determine the rejection, will the border line. Okay, so which the border line, which area that you reject and which area you don't reject. Okay, all right, so go to the example directly. Okay, so that you can understand more how to determine the rejection and non-rejection. Okay, so first we start with the two tail. Alright, so the average cost of a hotel room in New York is said to be 168 per night. Okay, so they say that someone claim that the average hotel, or maybe based on the report, okay, so hotel room in New York is said to be 168 per night. To determine this, if this is true, okay, a random sample of 25 hotel is taken and resulted in an X bar. This is X bar average. Okay, average cost of hotel is 170. Based from this 25, okay, they find out that they get the value. Okay, X bar is $172.50 and standard deviation is 15.4. Okay, $15.40. Okay, so and we will test the hypothesis at the alpha value 0.05. Okay. All right. So highlight. Sorry. 25 hotels. You get the sample from 25, and they claim that room should be 168. Okay, per night. So this is a two tail. Okay. All right, so first you have to highlight, take it out all the necessary information. So N is 25, X bar 172.5, S 15.4, S, and okay, so now 168 is mu. Okay, mean population, because it said all the hotel. Okay, the average cost of all hotel room in New York is 168. Okay, and then alpha value is 0.05. Okay, so alpha. All right, so because this area highlight you two tail, then you know it's two tail. If not, then you can identify here based on the statement. Okay, so the average cost of a hotel is said to be 168. Okay, doesn't mention whether should be more than 168 or less than 168. Okay, if the statement said that the average cost of a hotel room is said to be more than 168, means that it's a one tail. Okay, because it's more than. Or the statement said that it's said to be less than 168. Okay, so means that it's a one tail. Okay, less than 168. Okay, so first you have to develop the hypothesis. Okay, hypothesis null and hypothesis alternative. Okay, hypothesis must be based on mu. Okay, all right. Okay, because this is a two tail, so you know two tail is equals to and not equals to mu is equal to 168 and not equals to 168. All right, so first you have to identify, okay, so this is the distribution here. Okay, so this is 168 in the middle here. Okay. All right, so now we want to identify the critical, the line, okay, the point here. Okay, what is the point that determine the critical area? So how we can determine this based from the alpha value. Okay, so alpha value for these two is 0.05. So automatically you know that the confidence level is 95%. Okay, because it's both area, total is 0.05. Okay, so to get this value, the critical here, okay, we should refer to the T table. Okay, so oh sorry, one more. Okay, because this is a T, so we have to determine the degree of freedom. Okay, so degree of freedom is n minus 1. So n is 25 minus 1 is 24. Okay, alright, so now you based on degree of freedom 24 and alpha 2 tail 0.05. So we go to the table and then 2 tail. Okay, refer to this row. Okay, 2 tail. Degree of freedom 24. 24. Alpha 2 tail 0.05. Okay. Alright. Then okay. 24. Okay. Okay, so 24. Here and this is 0.05, 2 tails. So this is a T value. Okay, 2.064. Okay, so T critical. Okay, so T critical equals to 2.064. Yes, okay, 2.064. Okay, all right. So 2.064 is here. Okay. 2.064 because on the left side is negative and on the right side is positive. 2.064. Okay. When you convert to the T distribution, okay, convert to the T distribution. Now the mean here is 0. Okay. When we convert to the T distribution, the mean is 0. Okay, so 0 here in the middle and the critical error is 2.064 and negative 2.64. Means that if you get the value more than 2.064 or less than negative 0.64, you will reject the null hypothesis. Okay, depends with the T calculation. Okay, then you have to calculate the T. Okay, to calculate T equals to okay, x bar minus mu divided by s divided by square root n. Okay, the formula there, right? So x bar is 172.5 minus mu is 168 divided by s 15.4 divide square root 25. Get the value. Okay, calculate t value, calculate t value here.
Yeah, 1 second.
Yeah, that's okay. Just calculate.
Excuse me, doctor. I think it's 1.461.
1.461.
61.
Okay, 1.461. Okay, so 1.461 in which area? Okay, so 1.461 it should be between 0 and 2.0, less than 2.064, isn't it? Okay, so this value we plot it in this distribution, so it should be around here, 1.461. Aduh, sorry, let me see. Okay, so 1.461 is this area, around this area. What happened? So 1.46, okay, this area. Okay, so should be between 0 and 2.064. Okay, all right, so less than 2.064 but more than 0, 1.61. Okay, so it's in this area. So this is a non-rejection region. Okay, non-rejection. So in the middle is non-rejection. Okay, so this area at the end of it is a critical area. The area that I already highlight is a rejection region. Okay, so what is the non-rejection and rejection region? Okay, so when you get the value, t value here is in the non-rejection region, means that your decision is do not reject the null hypothesis. Because it's fall in the non-rejection region. Do not reject the null hypothesis. Okay. Alright. Or fail to reject null hypothesis. Okay. Either do not reject null hypothesis or you can put it as fail to reject null hypothesis. Okay. So when you fail to reject, okay, fail to reject means that the hypothesis null is true. Okay. Okay, so the hypothesis null is true lah. Because you cannot reject. We cannot make a conclusion that instead of we said do not reject the null hypothesis, we say okay, so we reject the alternative hypothesis. Cannot. Okay. Alright, so it's definitely we should, whether you reject null hypothesis or do not reject the null hypothesis. Okay, so if it falls, the t value falls in the non-rejection region, so the conclusion is do not reject the null hypothesis, means that null hypothesis is true. So null hypothesis is the statement is true. Means that the average cost of a hotel room in New York is you prove that it's 168. Okay. Alright. Okay, so this is a calculation. So you see, when you do not reject the null hypothesis, okay, so we cannot claim that that the cost is different from 168 lah. Okay, so or that you can say we have sufficient evidence to show that the cost of hotel in New York is 168. Okay, so it's either one lah. Okay, the conclusion there. Okay, so either you reject or either do not reject, or also that you can make a statement that fail to reject the null hypothesis. Okay. Alright, so any question about this? Before I proceed to one tail?
No, doctor.
Okay, no question. Alright, so now one tail. Okay, one tail test. Okay, so one tail test either more than or less than lah. Okay, so more than if it's based on the hypothesis null. Okay, alternative hypothesis. Okay, if hypothesis testing is less than mu is less than a number, so it's a lower tail. Alternative hypothesis is more than, mu is more than or equals to numbers, that is a upper tail test. Okay. Alright, so based on the null hypothesis, alternative hypothesis. Okay. Alright, so the step same as previous. Okay, only the difference is that when you determine the area based from the hypothesis, okay, only one area. Two tail hypothesis, you have two area for rejection. One tail, either upper or lower, a different area. Okay, lower tail is in left side, the rejection region. Upper tail is on the right side. Okay, so the rejection region. So but only one tail. So that is the difference only. Okay. Alright. So before I go to the example, so let me show you one tail and lower tail test and upper tail. Okay. Alright. Still normal distribution. Okay, so this is a normal distribution. Here, okay, so upper tail test is that the rejection area is in this area. Okay, or lower tail, the rejection area is on the left side. Okay, right side or left side, lower tail or T test. Okay, T test like upper tail, right? Okay, so alpha, okay, two tail you have to divide by alpha, alpha divide by 2, but for one tail, alpha is only in one area, so you didn't have to divide by 2. Okay, still to identify the critical area based from the alpha value or confidence level. Okay, alright, so now you already do the data collection. Okay, and then you get the phone industry manager thinks that customer monthly cell phone bills have increased. Okay, and now average over 52, means that more than 52. Okay, because it's increased. Okay, per month. Alright, the company wishes to test this claim. Okay, you want to test this claim that average monthly cell phone bill is more or over 52. Okay, so suppose a sample is taken with the following result. Okay, n equals to 25, x equals to 53, x bar. Okay, so this is x bar. Okay, so x bar means that they take a sample from 25 sample. Okay, so now they get the average phone bills is $53, 53.1. Okay, $53.10. And the standard deviation, sample standard deviation is equals to 10. And they will base on the alpha is 0.1. Okay, so and this is one tail. Okay, all right. So now first you have to develop the hypothesis. Okay, hypothesis null and hypothesis alternative. Okay, remember based from the statement, we have to put the statement here in the hypothesis alternative. Okay, all right. So mu, okay, over more than 52. We cannot put more than or equals to, right? Okay, so mu less than or equals to 52, the opposite. Okay. Alright, alternative opposite of null. Null is opposite of alternative, but equal sign must be in a hypothesis null. Okay, so first you have to develop the hypothesis. So after you develop the hypothesis, okay, then you have to highlight the information lah. Okay, so n equals to 25, x bar 53, s 10, and alpha is 0.1. Okay, so alpha 0.1. Okay, so then if we transfer in the distribution here, okay, so it's more than, so is it upper tail or lower tail? This one is upper tail, is one tail, but is it upper tail or lower tail?
Upper tail?
Upper tail, okay, upper tail on the right side here. Okay, why is it upper tail? Because it's more than, okay, more than 52. Okay, so upper tail, so alpha value is 0.1. Here. Okay, so the rest is, all the rest here is 90%. Okay, so 0.1, alpha 0.1, then 90% here. So next, you want to refer to identify the critical here, area here, the value here, or to the border to differentiate between the rejection and non-rejection. Okay, so this is the rejection, non-rejection. This area is non-rejection. Okay, so this one is rejection. Okay, so this is will determine the area that you will reject or you do not reject the null hypothesis. Okay, all right. So how to determine this value based from the alpha and degree of freedom. Degree of freedom is n minus 1, 24. Alpha is 0.1. Okay. Okay, so one tail, okay, one tail 0.1 here, okay, and n is still same 24. Okay, so now 24 and 0.1. Okay, okay, so let me erase first. Okay, so now we refer to one tail. Okay, so 24 and 0.1. Okay, so value is 1.318. Okay, so value here, T critical 1.318. Okay, so the value here is 1.318. So if when you calculate T, okay, so if you get more than 1.318, then you will reject the null hypothesis. Okay, so if you get less than 1.318, okay, either it's positive or negative value less than that value, then you do not reject the null hypothesis. Okay, all right. First, how to determine that whether it's a reject or not reject. Reject, then you have to calculate. Okay, so T x bar minus mu divided by S per root n. Okay, so x bar 53.1 minus 52 divided by 10 per root 25. Okay, to calculate T value,
It's 0.55.
Okay. 0 point.
55.
Okay, so 0.55. Okay, so 0.55. So 0.55 in which area? Non-rejection or rejection region? Fall in which area? In which region?
Non-rejection, I think.
Yes. Okay. So this is in the middle is 0. So 0.55 is in between 0 and 1.318. So somewhere here. Okay, 0.55. Right, so 0.55 in non-rejection region. So means that we do not, conclusion is that do not reject null hypothesis. Okay, when we do not reject the null hypothesis, means that the hypothesis null here, okay, go back to the hypothesis null, this is true. Okay, this hypothesis null is true lah. Okay, because you cannot reject. Okay, so means that the claim is not that that we don't have a sufficient evidence to prove that the average phone bills is now over $52. Okay, because the claim here we put it at average is more than 52. When we do not reject null hypothesis, means that this is true and this one hypothesis alternative is false lah. Okay, because null hypothesis is only true. Okay, alright. So alternative hypothesis is that the claim is average over 52. But based from your sample that you don't have evidence to prove that average bill now over 52. Okay. Alright, that's why the most important when you do data collection, you have to collect the you have to make sure that you collect from the proper sample. Okay. And it's better, you can get better result if your sample, you get more sample. Okay. So then you can get a clear picture to see whether is it correct or not, that the conclusion when you make a conclusion. Okay. So now that your conclusion based from this 25 sample, okay, we make a conclusion that the average phone bill is not over 52 lah. Okay. Alright. So we don't. Okay. So in the use based on the statistician words. Okay. Alright. We said that we don't have a sufficient evidence that the bill is over 52, okay, because we do not reject the null hypothesis. Okay, so this is a proper punya diagram. Okay, so you can see clearly. Okay, so this is from table. Okay, from table. Then when you calculate T, okay, when you calculate T here, then you can see that T this value is between 0 and 1.318 is in the null rejection region. So you do not reject the null hypothesis. Okay. All right. So next is no, not this one. Okay, for population proportion. Okay. Right, so for population proportion, everything is same, only that your hypothesis about proportion. Okay. And also that we will use a symbol for population proportion, P. P bar is for sample proportion. Okay, P is for population proportion. Okay, others than that is similar. Okay, so one tail, you have two tail, and then you have two tail. This first two is one tail, and then the last one is the two tail. Okay, all right, upper tail, lower tail. Okay, and then two tail. Okay, lower tail, upper tail, and two tail. Okay. Alright, so only that okay, so for population proportion, we will use a Z distribution, same as estimation, okay? And then to identify the critical region, the rejection region or non-rejection region, still based from the alpha value, and then we refer to the Z table, okay, or Z statistic, okay? And then after you identify the critical area and we calculate the Z statistic using this formula. Okay, so P bar minus P divided by square root P times by 1 minus P divided by N. Okay. Alright, so using this formula and then we compare is either in the non-rejection region or in the rejection region. Okay, in which area. Right. Okay, so then you can make a conclusion. Okay, so now we go directly to the example here. Right, so a marketing company. So this is for two-tail first. Okay. Okay. A marketing company claims that it received 8% response from its mailing. Okay. To test this claim, a random sample of 500 was surveyed with 25 response. Test the alpha. We will use the alpha 0.05 to test this hypothesis. Okay. Alright, so same as the mean. Okay, so first we have to develop the hypothesis, or first you highlight the important, okay, important information. Okay, so this is 8%, and then you take a sample 500. From this 500, okay, identify that 25 will respond to the mail. Okay, they send 500 mail and only 25 will respond. Okay, and then the alpha is 0.05. Okay, all right. So we go first. Calculate P. Okay, so first you have to calculate P bar. Okay, 25 divided by 500. Okay, N is 500. Alpha 0.05. P proportion population is 0.08. Okay. Alright, so now you develop the hypothesis H null and HA. Okay, so P here and P here. Okay, so the statement is that a marketing company claims that it received 8%. Okay, it's not more than 8% or less than 8%. Okay, so it's a total equals to or not equals to. Okay, 0.08. Okay, 8%, 0.08, right? Okay, so then you have to identify the critical area and the critical okay, it's a two-tail here. Okay, so identify the critical area here based on the alpha value. Okay, so alpha is 0.05. Based on the t distribution, then we will based on the sample size. But Z distribution is just only based on the alpha value. Okay. Okay. So alpha 0.05 means that alpha 0.05 means that the confidence level is 95%. So the value is 1.96. Okay, 1.96 here. 1.9. Push. Negative and 1.96 here. So this is 0.025 because you divide by 2, 0.05 divide by 2, and this is also 0.025. Okay, so in the middle is 95%. Okay, so 1.96, and then to determine whether you reject or do not reject the null hypothesis, then you have to calculate, okay, Z. Calculate Z, okay. Let me see, sorry. Okay, alright, so P bar minus P divided by square root P 1 minus P divided by N. Okay. So P bar is did anyone calculate P bar? 0. 0.05, isn't it? P bar. 25 divide by 5.
Yes, it's 0.05.
0.05. Okay. All right. So 0.05 minus 0.08. By N is 500. You get the value? Not yet.
Is it divided by 50?
500. Sorry.
100, yeah. I think it's negative 2.4.
2.4.
Yes, I think
Negative
so.
2.4. Right? Okay, so if negative 2.4, so in which area?
Mm.
In this area, isn't it? 2.4, negative 2.4, less than negative 1.6. So it falls in the
It gets rejected.
rejection region. So when it falls in the rejection region, then the decision is to reject the null hypothesis. So when we reject the null hypothesis means that the null hypothesis is not true. Okay, so alternative is true. Okay, so because we reject the null hypothesis. So the claims that marketing company claim that it's 8% receive 8% response, we don't have sufficient evidence to prove that a company will receive 8% response lah. Okay, it's not exactly 0.08 or 8%, right? Okay, or maybe the other way. Okay, so it's either you can say there is insufficient evidence, okay, to prove the claim that it will receive 8% response, or we can say that we have a sufficient evidence to reject the claim. Okay, all right. Okay, so that's two tail. Now we go to the last part of the hypothesis testing is a one tail. Okay, so one tail is quite different from the two tail, and also that two tail, one tail we don't have a specific table for one tail. Okay, I mean that the specific table for one tail, we don't have a combination table for two tail and one tail for Z distribution like a t-test. Okay, so it's different, right? So when there is a one tail, then is to identify the critical area is different from the two tail. Okay, all right, so let me show you how to this table. This is a Z table. Okay, sorry. Okay, so can you see my whiteboard?
Yes, doctor.
Okay, so let's say we have an alpha value 0.05. Okay, all right, so 0.05 but only one tail. Okay, so one tail here. Okay, so this is 0.05. 0.05. Okay, so 0.05, one tail. Okay, so the rest here is 95%. Okay, 95%. But remember in one area, okay, so it's different, okay, it's quite different from two tail, okay. Okay, let me show. This is a two tail, 0.05. Okay, so this is 0.025 and this is 0.025. Okay, so in the middle is 95%. 95, right or not? Okay. Alright, so in the middle 95%. Okay, one area is 0.475. Okay, so in this area also 0.475. Okay, so if you refer to the value, okay, so to the one that I give it to you, Z value to 95%, 90%, 98%. Okay, so if you refer to that value, 95% confidence level, you will get 1.96 here. Okay, how do you get 1.96? It's actually based from this value, 0.57. 0.57. Okay, so because it's in the middle, okay, so 95 divided by 2, then you get 0.57. Okay, all right, so how do you get 1.96? We can find the 0.57 in this table, okay, in the middle here. Okay, 0.477, 0.474, 0.475 here. Okay, 0.475. Okay, 0.475 here. Okay. Alright, so 0.475, then you see the value here, 1.96. Okay, this is how you get 1.96. Okay, so sorry, this is a negative. Left side is the negative, right side is a positive. Okay, that is how you get the 1.96. Similar as let's say if 90%. Okay, so So 90% in the middle here. Okay, means that this is a 5% and this is 5%. 5%. Okay, so 5%, so means that this is 0.5, 0.45 and 0.45. Okay, the total on the left side is 0.5 and also total on the right side also 0.5. Okay, right, because this is already, this area already 5% and this area already 5%, so 0.5 minus 0.05, then you will get 0.45, or 90%, 0.9 divide by 2, then you will get 0.45. Either one lah, okay. Alright, so 0.45, find the value 0.45 here. So it's in between these two figures, okay. 0.0495 and 0.4505, okay. Alright, so the value is in between here, in the middle here, okay. So you can see 1.94, okay, because it's in the between 0.04 and 0.05, that's why you get the value 1.645 negative, or 1.645, okay, because it's exactly in the middle here. Okay, 0.45 is in between 0.4495 to 0.505. Okay, it's in the middle. All right, that's for two tail. Okay, so how we can read? Okay, two tail, one tail. All right. Okay, so alpha 0.05 and it's one tail. Okay, so one tail. Let's say upper tail first. Okay, so 0.05. Okay, one tail, only one side. Okay, so means that in this one is 0.0. Okay, 0.5. Okay, and this area is 0.45. Okay, because it's effect only the rejection area only in this area. Okay, even though if it's lower tail, okay, lower tail, so this is 0.05. Okay, so this area is 0.45 and this one is 0.5. Okay, so make that the total here is 0.95. Okay, so first you have to identify that. So when we get 0.45 here, so go to the tab, refer to the table 0.45. Okay, so 0.45 here is in between, or same as previous. Okay, but the previous is 0.01. Okay, all right, so 0 is in between here, this value. Okay, exactly in the middle. So 1.645 here. Okay, all right, so 1.645 or negative 1.645. Okay, so that's how you refer to the table. Okay, for one tail. Okay, all right, so any question? Okay, so no question. So I will show you the example for one tail. Okay. Okay, have you read? Alright, so the owner of a popular internet based auction, based auction site believe that more than half of the people who sell items on her site are women. Okay, alright, more than half of the people who sell item on her site are women. Right. To test his hypothesis, the owner sample 1,000 customer. Okay, because the owner believe more than half, more than 50%. Okay. Alright, so the owner sampled 1,000 and then found out that 53% of the customer sample were women. Okay, if you were to conduct a hypothesis test to determine if greater than 50% of customer who use this internet-based site are women, would you conduct a one tail or two tail? Okay, of course, one tail. You know, this is example for one tail. Okay, it's a one tail, okay, because you want to test is greater than 50%, okay, not you want to test whether it's a 50% or not. You just wanted to test whether it's correct or not. It's more than 50%, okay. Alright, using a 5% significant level, can the owner of the site conclude that women make up more than 50% of her customer? Okay. Alright, so the owner sample 1,000, okay, and then from that you get the 50%. They want to test if greater than 50% is a woman, okay, and will be based on 5% significant level, okay. Alright, okay, so N is 1,000, P per 0.53, P is 0.5, alpha is 0.05. Okay, alpha is 0.05. It's a one tail. Okay, so now how you create the hypothesis? What is the hypothesis null and what is hypothesis alternative? Okay, so it's P and P. Which one is more than, which one is less than? Hello, which hypothesis is more than? A null or less than? Null or alternative?
Is 53 more than?
No, which alternative? Null or alternative? Like I mentioned previously, okay, so whatever an assumption that made based on the previous data or belief or there's a claim from the other person, we should put it in the alternative hypothesis, okay. Alright, so I want to test whether more than 0.5, so P bar more than 0.5. So the opposite of null is less than or equals to 0.5. Okay, 50% is 0.5. Okay, so then is it lower tail, upper tail? It's upper tail, okay?
Upper tail. Yeah.
Upper tail, okay? Upper tail, so this is 0.05, okay? So refer to the table 0.05 based on alpha 0.05 like I did show you. So 0.05, one tail is 1.645. Okay. Alright, so then 1.645, then so if more than 1.645, you will reject the null hypothesis. If you calculate Z and you get less than 1.645, then you do not reject the null hypothesis. Okay, so now you have to calculate. Okay, so P bar minus P n. Okay, so P bar is 0.53 minus 0.5, 0, divided by n is 1000.
I believe it's 1.8.
1.8. Okay, so 1.8 is more than or less than 1.645?
More than.
More than, so it should be in this area. Okay, 1.8. So means that what is your decision?
Rejected.
Reject null hypothesis. Reject null hypothesis. Okay, so when you reject the null hypothesis, means that the null hypothesis is not true, alternative is true. Okay, so alternative is more than 0.5. So you have sufficient evidence to prove that more than 50% of the customer are women of this side lah. Okay, alright, so more than 50% of her customer is woman, are woman, right? Okay, do you have any question?
No, doctor.
Okay.
It's just confusing.
Confusing, which one? I don't know.
Overall.
Okay, so overall I cannot do anything. You have to go back and study yourself, okay?
Yes, yes.
Alright, okay, that's all. I just wait until I complete this chapter 6, then I will share the video lah, okay? Now we already complete, and next class we'll start with new chapter that I will share this. So you can go back and revisit the video, okay? Right, okay. Okay, bye-bye.
Thank you, doctor.
That's all for chapter 6, and also that's all for class today. Unless you have a question to ask me. If not, I think that's all of today.
Okay, thank you, doctor.
Okay, all right. Okay, bye-bye.